Hey guys, so today I don't have my husband slash videographer, so I'm going to be making two videos, one for the front of the page notes and one for the back of notes. So there's a lot of vocabulary in this lesson. It's an introduction to polynomials, and that phrase, that prefix poly means many, right? So before we talk about many, let's talk about one. Mono means one, right? So a monomial, this may sound a little not make a lot of sense, but a constant or a product of a constant and any quantity of variables. The way I like to think of that is a term, right? So the thing about monomials is that exponents on them have to be whole numbers. They can't be negative, they can't be fractions, they gotta be whole numbers. So like 0, 1, 2, 3, etc. The degree of a monomial, so there's the definition of a monomial. The degree of monomial is the sum of all the exponents on the variables. So let's look at, these are all monomials. How do I tell that they're monomials? I can tell because there's no pluses or minuses that separate them from the next term. So even though there's multiple variables here, there's no pluses or minuses in between. They're all one unit. So if I don't have an x at all, there are no exponents on the variable, so I'm just going to say 0 for the degree. Same thing here. If there are no exponents, I'm going to say 0. Okay, here I do have an exponent, and we know that that's 5x to the first. So the degree here is 1. Now we're moving up in the world. We've got a cube here, so the degree here is 3. Now these both have one variable, right? But what if I now have two variables in my monomial? Well, I'm going to add up the exponents. So in this case, the degree would be 6, right? And in this situation, we can't forget that this is z to the first. Right, I would add 5 plus 2 plus 1, which is a degree of 8. Right, so those are all single terms. Now, what if we start putting pluses and minuses between those terms? If we start doing that, then we have polynomials. So a polynomial is taking monomials and adding them and subtracting them, putting them like 6x plus 2 minus 3x, like that. I also have, even though I have a bunch of different terms, I can find the degree of the polynomial by picking the term with the highest degree, and that's the one that determines the entire degree of the polynomial. So it's also important to look at things that are not polynomials. So like we said, fraction exponents, not polynomials, right? Square root of x is actually x to the 1/2, which is a fraction. What if I have variables on the bottom? Not a polynomial, because that's actually a negative exponent. Remember we said they have to be whole numbers. Again, no fraction exponents. Can't have that. And then here, the variable is the exponent. So we don't even know what that exponent is. It could be a fraction, it could be who knows, right? So those aren't polynomials. So I'm sure you're really itching to see some actual polynomials. So just like human beings, guys, you have a first name and a last name. Polynomials also have a first name and a last name. So their first name is their name by degree, right? So depending on their degree, they have different names, right? Now I'm going to let you read these rather than read through all of them. Their last name is by their number of terms, right? So anything 4 or more, there are actually names for 4 or more, but we're not going to bother with remembering those. We just want to remember monomial, binomial, and trinomial. Okay, so here are the things that we care about with polynomials, right? We care about putting them in standard form. And by standard form, I mean the highest. I want the exponents, the terms, in descending order of exponents, starting with the highest, going all the way to the lowest. So x to the third is the highest exponent here. Then x to the second. Then x. And then plus 5. Now, one of the great things about why we put it in standard form is it's really easy to see the degree and the lead coefficient. So once I have them in order, the degree is going to be the highest exponent here, right? That's the lead term. So that degree is the one that wins, right? And the lead coefficient is the number in front of that lead term. So in this case, that's -7. Okay, guys, how do I tell where one term ends and the next one begins? Well, I tell by whether there's pluses and minuses, right? Pluses and minuses separate the terms, right? So I can tell that it's -7x to the third is one single term because then it becomes 4x squared. So there are 1, 2, 3, 4 terms in this polynomial, and it's a degree 3. So its name by degree is going to be cubic, and since there are 4 terms, we're just going to use the generic polynomial. Okay, guys, the next one, they're being really tricky. They want you to say it's degree 2, but that's not an exponent on a variable. 5 squared is just 25, right? So the degree here, there is no x. So that means the degree is 0, and there's one single term, right? So our lead coefficient is just that single term. Okay, guys, so like we said, there's a single term, so we're going to call it a monomial, and it's a degree of 0. So we're going to call it a constant monomial. Okay, guys, next one, standard form, 5x squared minus 8. The degree is 2, the lead coefficient's 5, and it's a degree of 2, which is quadratic. We know that because we just did a unit on quadratics. Quadratic, and then there's 2 terms, the 5x squared and the -8. So that's a binomial. Okay, guys, next one, -4x plus 7. Now, normally in the classroom, I would have you guys come up and do these. So this is x to the first, right? So this is a degree of 1 and a lead coefficient of -4. So if I look over at degree 1, it says it's a linear binomial, right? Because there are 2 terms. Okay, I'm going to scooch this up a little. Okay, let's put this in standard form. -3x squared plus 8x plus 3. Degree is 2. Lead coefficient, -3. And we've got ourselves a degree of 2 is quadratic. And we have 3 terms. 1, 2, 3. So that's a trinomial. Okay? Now we've got 7x cubed plus 5x squared plus 2x minus 8. We've got a degree of 3. Our lead coefficient is 7. And this time we have a cubic, because it's a degree of 3. And there are 4 terms, so we're just going to call it a polynomial. Okay, guys, 3 more to go. Now, that has a fraction, and it says we need whole numbers, but we need whole number exponents, right? The exponent is a 2, so I can have a fraction coefficient. So that gives me a degree of 2, and my lead coefficient is 9/2. So this is a quadratic binomial. Okay? Ooh, now we've got an x to the 5th. Right, guys? So an x to the 5th is a degree of 5. The lead coefficient here is a 7. And now we have a quintic, degree 5, trinomial. Okay, guys, last one. -x to the 6th plus 6x to the 3rd plus 1. Okay, guys, that's a sixth degree with a lead coefficient of -1, right? Because that's a -1 there. This is a sixth degree. Anything above sixth degree, we're just going to say, anything 6th degree or above, just going to say 6th degree, 7th degree. And this is a trinomial. Okay, guys, I will be back in a minute for the next video.